attenuation plates. So indeed, so let's go back to this BB84 protocol and speak about a bit more a kind of modified version of BB84 protocol, which is called decoy states. So let's imagine that Alice once again sends information to Bob, and once again we have if, and we know that in real life actually so this laser attenuation plate would actually transmit indeed one single photon as we want, but sometimes because it's governed by this Poissonian statistics, it would transmit like one or two or even more photons. And what if could do? She could actually introduce some kind of beam splitter here in the middle, and she could take the photon. She could send one photon for Bob, and she could leave one photon for herself. And because actually the single photon generation, the current single photon generation methods are not ideal, therefore channel communications over this channel would be disturbed. And if would actually for example, could keep these photons for a while. I know with some kind of quantum memory, and after Alice and Bob would exchange the measurement basis, if could actually measure and decode all the information that was sent between Alice and Bob. So yes, so yes, so one interesting way to actually solve this problem is to so here a few words about the single photon itself. So single photons actually generation, for example, by using laser attenuation plates are governed by this Poissonian statistics. So we know that we have a very high probability if we have, for example, a laser source that would emit a single photon, that expected value of photon emission would be 1, would have a very high probability indeed to emit one photon, but it would also have some kind of probability to emit multiple photons. And this kind of distribution is called Poissonian distribution. And as you can see, as the mean number increases, it resembles more to the Gaussian distribution. So that's the reason that when you actually transmit one photon through this non-ideal single photon generation device, you could actually send one, or you can send two or more photons. So so let's imagine right now that Eve and Bob think of a very innovative way to actually communicate. And what they do, they would Alice on her side, she would have two sources of laser intensity. So she would have one source of laser light intensity, for example, 0.1, another laser light intensity of 0.2. So after performing the measurements, they would indeed, Alice and Bob, once again, they would share the basis themselves, and afterwards they would know, and so afterwards they would check what kind of bits they got detected. For example, Bob would know what kind of bits bits he detected, and Alice also would share the intensity with which she sent those bits. So for example, she know that bit 1 was sent with intensity, first intensity, bit 2 was sent with, for example, with 0.2 intensity, etc. And what would happen that Bob would also share this information with which intensity he detected the photons themselves. And if they would know that, for example, the distribution of the intensity detection would mismatch. So if there will be lots of photons that would be detected with incorrect intensity, then they would know that they detected intensity. So if Bob would detect a lot of photons with a lower intensity than it should be, so for example, then they would know that there is a presence of Eve on the channel, and that actually Eve fishes out some photons of the high intensity. So Alice therefore has successfully introduced this type of decoy state to catch Eve. So by also sharing the intensity with which she sends photons, Alice can secure the channel.